Okay, picture this. You wake up, check your phone, and your web apps traffic just tripled overnight. I mean, sounds like the ultimate dream, right? You went viral. But if you're running a traditional single instance setup, yeah, that dream is instantly a nightmare. Servers overload, the app crashes, your customers are furious, and you are literally watching revenue evaporate. Total panic. But what if your infrastructure could just, automatically adapt on the fly? Welcome to the Explainer. Today we're making sure you never have to live through that nightmare scenario. We're totally demystifying AWS high availability, scaling, storage, and pricing. And we aren't just going to throw theory at you. We're going to break down a practical, real-world case study to see exactly how resilient cloud architecture is built right from the ground up. Here's our game plan for today. We'll start with the high availability problem, then move into scaling and availability zones, building a resilient architecture, choosing the right storage, optimizing your cloud costs, and finally, putting it to the test. All right, part one, the high availability problem. So, high availability. It's essentially the holy grail of modern web infrastructure. We have to understand the flaws of old school server setups to actually fix them. High availability is the capacity of your system to just keep running without interruption, even when, not if, but when, hardware, software, or network failures hit. Because in today's digital landscape, downtime isn't just a temporary oops moment. It's a direct hit to your bottom line and a massive blow to user trust. Now, achieving high availability used to be a massive headache. You basically had two pretty terrible choices for capacity planning. Approach one, you buy way too much capacity just to handle potential peaks. The catch? You're burning through cache on servers that just sit there doing nothing during normal hours. Or, approach two, you buy just enough capacity for average traffic to save a few bucks. But the exact second your traffic spikes, boom, the site crashes and your customers are getting a horrible experience. Section 2, scaling and availability zones. Obviously, neither of those old approaches cuts it anymore. We need something smarter. Enter Amazon EC2 auto-scaling. This is a total game changer. It gives us a third, vastly superior option. It provides better fault tolerance because it constantly monitors server health and instantly swaps out any bad ones. It gives us better availability by automatically spinning up new servers the second traffic surges. And, maybe best of all, better cost management. It dynamically kills off those extra servers the moment traffic dies down. You literally only pay for what you use exactly when you need it. But auto-scaling is really only half the puzzle. What if a power outage hits the physical data center holding all your servers? That's where availability zones come in. These are physically isolated locations within an AWS region. By purposefully spreading our auto-scaled instances evenly across multiple isolated zones, we completely wipe out the risk of one single point of failure taking down the whole operation. Moving on to Section 3, building a resilient architecture. Okay, so that's the theory, but let's explore how researchers from the European University of Tirana put this to the test by building a highly available 3-tier AWS web app. Think of the whole setup like a secure fortress. The outer perimeter is a virtual private cloud, or VPC, which acts as a protective fence around all our resources. And inside that fence, traffic is intelligently directed by load balancers across those multiple availability zones. Let's break down how these three independent tiers actually function. Step 1 is the front-end tier, where your web servers live. Traffic hits a public application load balancer first, which seamlessly passes users to healthy EC2 instances. Step 2 is the back-end tier, handling all the core application logic. Notice that this one sits safely behind an internal load balancer, completely cut off from the public internet, which is huge for security. And step 3 is the database tier, using Amazon RDS in a multi-AZ setup. Basically, if the primary database goes down, a perfectly synced standby in a totally different zone instantly takes over. If one layer fails, the damage is totally contained. It doesn't cascade and sink the whole ship. Section 4, choosing the right storage. Now, an architecture is really only as strong as the data it holds. In AWS, storage generally falls into three main buckets. You've got block storage like Amazon EVS, perfect for single-instance databases, object storage like Amazon S3, which is incredible for massive scale and backups, and file storage like Amazon EFS, letting multiple instances access shared files at the exact same time. For the EC2 instances actually running our web app, we rely heavily on Amazon EBS, or Elastic Block Store. Think of EBS as a high-performance physical hard drive plugged straight into your cloud server. The magic word here is persistence. Even if your instance gets terminated or, automatically swapped out by auto-scaling,
the data on that EBS volume sticks around independently. You don't lose everything just because a server got replaced.
Contrast that with Amazon S3. While EBS is all about active, high-speed computing, S3 is your highly reliable, super inexpensive, bottomless vault. You definitely wouldn't run a live database directly off S3, but you absolutely use it to lock away your critical backup copies, like those automated snapshots of your EBS volumes. It's just a huge relief knowing that Failsafe is always humming along in the background.
Section 5. Optimizing your cloud costs.
Let's be real for a second, though. A beautifully architected, ultra-resilient system is completely useless if it bankrupts your company, right? So how do we pay for this without setting our budgets on fire? Well, AWS has two primary pricing models: on-demand and reserved instances. I actually love this quote from the AWS documentation to explain it. Compare this to renting a car park in the city for a year or on a daily rate. On-demand means you pay by the second, zero commitment. It's super flexible, but yeah, it's that premium daily rate. Reserved instances lock you in for 1 or 3 years, but give you a massive discount. It's exactly like signing an annual lease on that parking spot. Let's actually look at the math here for a heavy-duty C5D.4x large server. If you lock in a 3-year reserved instance, it costs a flat $92,224. Now, what if you only end up using that server 50% of the time over those 3 years? Well, paying the flexible on-demand rate for that exact same usage would run you over $12,000. By reserving it, you're keeping over $3,300 in your pocket, even when the server is just sitting idle half the time. If you know your baseline capacity needs, reserving is literally a no-brainer. Finally, Section 6, putting it to the test. All right, we've got the resilient architecture, the storage is secured, and the budget is optimized. But did the academic researchers prove this actually holds up? They absolutely did. They didn't just deploy the code and cross their fingers, they threw a complete gauntlet at this system. They ran intense performance load simulations to make sure auto-scaling really kicked in during traffic spikes. They did failover testing, literally pulling the plug on servers and databases to watch the automated recovery kick in without dropping the app. They ran penetration tests to ensure the backend was practically invisible to the internet. And they tracked every single penny via AWS Cost Explorer to prove the scaling policies actually kept the bills down. And the verdict from the study? The architecture did exactly what it promised. It massively enhanced resilience, totally minimized single points of failure with that multi-AZ deployment, proved it could automatically recover from localized crashes, and it kept a very tight leash on operational costs. It's basically a proven, rock-solid blueprint for any modern web application. Which brings us to the end of this explainer and leaves us with one incredibly important question to take back to your engineering teams. Is your current infrastructure genuinely built to survive inevitable failures, or are you just hoping for the best? Because out there in the cloud, hope is definitely not a strategy. But as we've seen today, high availability absolutely is. Thanks for hanging out with me on this explainer, and keep building resilient systems.